Okay, so as Andre said, I will give a short introduction into Python and also the matplotlib, which is a plotting tool for Python, which you can use to replace the plotting that you usually do with MATLAB. Okay, so what we will learn in this first session here is first how to use the Python console and how to write Python scripts. Then I will give an introduction into the Python programming language and some details of that. And at the end, I will show briefly how you can plot with Python. The first thing what you would like to do when you work with Python is to start the Python interpreter. So maybe a footnote: everything that is marked yellow is actually for you to type. So this is a hands-on. That means that every single command here on the slides work. So and if you maybe it's a good idea for you to get a grasp on that and to really try the commands out. So starting the Python interpreter, here we just go to the console. So you open a terminal on your notebook and you type Python. And what you will see is after you get some messages, you will see 3 arrows. And that's it. So you do not actually know what you can do with that. So the first thing about Python is that Python is divided into so-called modules. And though the Python language is already quite powerful, it is most of the real computing is done in modules. So for example, the sys module that I will use in this example provides some system tools. But so and to be able to use these modules, you have to import them by typing import this in this case. And since you probably do not know what is in this sys module, there is an integrated help function in Python, so that you can just type help, then you give the sys module, and what you will get is a help page like this, which says that the module is this, that it's a built-in module where you can find documentations for that, and what is contained in this module. For example, there's an argv command line arguments, and argv of 0 is a script path name if known. Okay. So you still don't know what argv is, so you try to type help sys.argv. And then you will get help on sys.argv, and you will see that it's just a list object. I will explain later what the lists are, but so you now know that this has an element called argv, and that this is a list object. And that has a specific function that we will use later on. Okay, one important thing to know is also how to close the interpreter, and this is done by typing exit with parentheses. So this is actually a function. If you forget the parentheses, then you will get a warning message, and to execute this function, you have to put the parentheses as well. That was the Python interpreter, but sometimes you want to store the information that to execute some commands multiple times, and then you would like to script something. So to script Python, you first open a terminal in the desired directory. You already have done that, and you open the editor of your choice. normal text editor. In this case, we will use gedit. You give it the script name, which should end with py. And when you have done that, you can write some code and save that. In this little example, please, when you write in gedit, do not type the line numbers. It's just an indication that this is a script. Okay, then as before, the first thing you always have to do is you import the modules that you want to use. And then, for example, we do a simple example. We print just my name is, and then the first command line parameter. Okay, so you save that, you go back to the command line, and you run the script. To run the script, you use the same command as before. You call Python, but now instead of pressing enter after Python, you give also the name of the script, and so it will run the script. And when you just run the script, you will get an arrow, which is intended just to show. Okay, yeah. Was everyone so far able to do that? So any problems? Okay, seems not. So if you then type Python script py, you get an index error, but instead of crashing, which other applications would do, you just get a detailed report on the error message, and you will see that you will point it out to this line and say, it says that there is an index error. And then you see, okay, yeah, right, I wanted to write the first command line argument, so I have to give it a command line argument. And when you run the script, calling Python, the script name, and the command line arguments, you will see that it will print the right thing. Yes.
So if you insert the space between the end of is and the argument.
Okay, that's a good question. So why there is no space between is and the argument? Because we have the comma here. And when you have a comma, this automatically inserts a space. Okay. Okay, so far to the introduction how to write Python and script Python. And now I will come to some more detailed description of the Python language. I will start with the variables, which is, as everything else in Python, case sensitive. And one important point for Python is that the variables are dynamically typed. That means that you do not have to write in contradiction, for example, to C++. You do not have to type write the type of the variable that you want to have, but this is automatically generated or automatically evaluated. So, for example, when you assign a 7 literal to a variable named a, and you ask for the type of that variable, then it will tell you int. And if you divide it by another int, let's say 2, then it will automatically take the integer division. When you do the same trick, but instead of writing an integer literal, you write a float literal, then magically the type of the variable will be float, and any operator used will be the float operator. In Python, there is also integrated a complex type, and so you can just create it by either calling the constructor of a complex value or just by typing a complex literal, which is indicated by the j, so 7 plus 5j. And the type is complex, and when you divide, of course, you will get the complex division. And also there's an integrated string class, which you can generate using the quotes. And in Python, there is no difference between single quotes and double quotes. So you can use both to indicate that it is a string. Here, I probably will always use single quotes, but as I said, it's absolutely no difference. And if you would use the division operator on this string, then you will get an exception again. But to convert this string into a number, there are so-called coercion functions, which just take the string, and so this is called a float. So you will create a float out of a string. Okay. Another note on variables in Python is that everything inside the Python language is an object. So when you import a module, it is an object as any variable as anything else. So, for example, if you do not like the name Bob, then you say, okay, we import Bob. We say Joe equals Bob, and now you can take Joe as use Joe with the same way you would use Bob. So you can, for example, Bob has a member called version. So you can say bob.version and you will joe.version and you will get the version of Bob. We will use this later when we have like long names that we import, so that we can just make an abbreviation to that. And another thing is that also functions are objects, which means that it's, so we have the function, the built-in function min, which just computes the minimum of two values. And this can be assigned to a variable. And this variable can then be used, can then be executed with two values, and this will behave like the min function. This will actually be the min function. What is interesting about that is that this leads to functional programming, that functional programming is an integrated part of Python, which is very hard to do in any other programming language, or most of the other programming languages. The next basic element of Python, which you will see throughout when you work with Python, is a list. A list is just a loose collection of objects. So a list is indicated by square brackets, and you can put in any object that you like. Here, for example, I put an integer 7, a float 3, a string, but you can also put in some objects, you can put in some functions, you can put in some class, whatever you like. There is, okay, when you're coming from MATLAB, maybe you might be surprised that indexing starts at 0, but this is in most, I would say, good programming languages the case. So when you when you want to retrieve an object from the list, then you can just index it with the position of the object in the list. So when you want to have the first element, you index it with 0, so it's actually the 0th element, and you will get the 7. You can also slice a list by giving the first and the behind the last element. So when you want to have the first and the second element, you say, so index 1 and index 2 elements, you say the list with index 1, 2, 3, because 3 is behind the last element that you want to have, and you will get a sub-list of that, which contains the 3 and the string. And interestingly, you can also use negative indices to index a list. and then it just counts backwards. So when you index with -1, you will get the last element. When you index with -2, you get the second last, and so on. And you can mix all these indexings as you like. Lists in Python are dynamically growing and shrinking. For example, if you want to remove an element from the list, you remove the element from the list. You do not have to care for the index of the element, but you directly say when you have a 3 in the list, you remove the 3 from the list. And when you print the list afterwards, you will see that the 3, which was at index 1, is removed. Yes. It's 1 to 3, because so you always say the first element, and then behind the last element that you want to have. So this is probably a concept that comes more or less from C++, where you have when you write a for loop, you start at 0 and you end at the last element, which is at the size which is behind the last element. Yes. To retrieve, so it's the -1, not the last. Okay. Yes, you can just leave out the last one. So if you would have said 1 colon, then you will get from the second to the end. And the same works the other way around. When you leave out the first index, then you will start from 0. Yeah, when you try to remove an element that it's not in the list, you will get an exception. But there are other functions in the list that, for example, to push and to pop, and no, push is not in Python, but to pop, so you will get the last element, and so there are more functions. Actually, this is here, down here, there is a link where you can go and check all the functions of the lists.
And also the help in the object.
Yes, help.
That will get you all the methods that the object has.
Yeah, but yes, that's true. You can also use the help method, but this is sometimes tricky because you get all the underscore functions first, so you have to scroll a bit. Yeah. Okay. And okay, so when you have a list, you can also append elements. So push it at the end, by just say append, you put an element, and it appears at the end. And you have some query functions. For example, when you want to know the length of the list, you just say len, which is also a built-in function, len of list, and you will get 3 when you did all that. You can check if the 3 is in the list using the special in keyword. And since we removed the 3 here, it should not be in the list anymore. And when you want to have the index for a specific element, you will just say list.index of this element, and you will get the index of the first element of that type. So you can have the same element twice, and you will get the first element. Okay. It's the same when you remove. If you have the element twice in the list and you remove, the first element will be removed, but the second will stay. And as I said, this is all explained in the tutorial introduction. Okay. The next data type that you will quite often use in Python is the dictionary, which is similar to a list, but instead of indexing with integral values, you can index it with basically everything. Here, so a dictionary is an associative, a list of associative key value pairs. So to create a dictionary, there are several ways, but the fastest way is when you know all the objects, you say key 1, which I call first, colon, value 1, which is 1, key 2, value 2, and you can have more. And you put that all in curly braces. And when you print it, then you will see that the elements have changed order. This is because the dictionary use some hash functions to convert, to store the keys and to order the keys. So, the hash function for second seems to be generate a smaller result than for first. And so that's why you get the second value print first in the first here. So the rule is you should not rely on the order of element in the dictionary. And when you have a dictionary and you want to assign a value there, you just, as I said, you index it with the name that you put here with the key, and you assign a new value. And when you then print the dictionary again, you will see that the value for the second key has changed, while the value for the first key is still available, still unchanged. And you can also simply add elements by choosing a key that has not been there before. So for example, third, you index it with third, you assign it a 3, and your dictionary will automatically grow. You can also remove elements, but I'm not talking about that today. And again, the dictionary has some query functions. For example, the key functions, which will return a list of keys. A values function, which will return the list of values. And these two functions use the same order, so you can be sure that the first element in the values belongs to the first element in the keys. And again, we have the length function, which tells you the number of elements. We have the in keyword, which checks if a specific key is in the dictionary. So when we ask if first is in dictionary, you will receive true, because it is. But if we ask if 1, which is a value and not a key, is inside the dictionary, you will get a false. Okay. So before I continue with the control flow building blocks in Python, I want to add a short note about indentation. When you do programming, it is a good practice in any programming languages that you indent building blocks. So for example, if you have a control flow statement here, it's an if statement, a while, a for loop, whatever. The inner block should be indented in any programming language. And the specialty about Python is that they enforce you to do that. So in Python, the normal building blocks look like that. You have a control flow statement, as I said, if, while, or, for. You have a colon, which separates, which says that now the inner block starts, and then you have to indent the inner block. By default, Python recommends to use 4 spaces, but actually you can use as many spaces as you want. You can also mix tabs and spaces, but as a recommendation, you should never do that, because otherwise it becomes completely unreadable. And you can set up your editor to replace tabs with spaces with a certain amount of spaces, and for the gedit that we edit in in the VDI, this is already set up, so that you can press tab and you will get automatically 4 spaces. All right. So, and about the inner blocks. So the inner block continues until you go back to the first line, and then the outer block starts again. When you indent something without having a colon before, you will get a syntax error. When you indent that with 2 spaces, you will get a syntax error when these are 4, and so on. So indentation is very critical in Python, and it is nice that Python enforces you to indent your code, because it makes the code much more readable in any programming language. Okay, now I will go on with the basic elements, the control flow elements. The first one is, of course, the if statements. So, for example, you write the if keyword, you write anything that will evaluate to bool, for example, a comparison operator, and you write the colon. I have to admit that these examples are very tricky to be written on the console, on the Python console. It's much easier if you write that in a script, but they work. You can try. Okay, so you write the colon, you indent your inner block. You're finished with the inner block. You de-indent to the first line. You write an else. You indent again. You could actually use a different indentation, but I will stick to 4. And if you press enter again, then this should print. Maybe you have to press enter twice or 3 times. This will print the result that it's smaller. There is while loops, which work similarly to while loops in other programming languages. So you write the while keyword, you write some expression that evaluates either to true or false, and as long as the expression is true, you will do the inner block. And here I just print x times x. Maybe you note the comma here at the end, because we were talking about the comma. This will, by default, printing will print line by line. And if you add a comma at the end, then it will just do not put a new line character but a space. So that the result of this is 1, 4, 9, 16 in one line and not in 4 different lines. So if you do not use a comma, you will just get the same but in 4 lines. An interesting control flow element is the for loops in Python, because for loops always iterates over lists, or in general iteratables. And it's a bit different to other programming languages, where you always iterate over indices or something. That is not the case in Python. You always iterate over the elements of a list, or maybe over the keys of a dictionary. So these are mainly the 2 things what you iterate on. And again, syntax is the same. You print the for keyword, then the variable name, the in keyword, and then the list you want to iterate over, a colon, and you write the inner block. Or here, for key in dictionary, print the key. And there is also one interesting thing in Python, which is called list comprehension, which can be used to convert the elements of one list or several lists into another one. So, for example, you can use so the for and the if statements inside such an expression. And when you write, so the list comprehensions always start with the list brackets. Then you write an expression, and then you write a for loop, and you iterate over some elements in the list. For example, here we want to convert the list 1, 2, 3, 4 into the squares of these values. And so we say we want to have x times x, or x squared, for all x in this list. And you will end up with a list containing the elements 1, 4, 9, 16, which are actually the squared elements of the list. And these list comprehensions can be much more complicated than that. Okay. The next thing I want to talk about is function definition. So a function can be defined using the def keyword. You write def, the function name, a list of parameters, the colon, and the body of the function. There are some default values possible, but as you might see, there is no type connected to these variables. So when you come from C++ or from Java, usually you have to define which type you expect. This is not true in Python. In Python, you just get anything. And you have to be careful how you call this function. And it needs a proper documentation, which again enforces you to proper document your code. Okay. In this function, I keep it quite simple. So there is an s parameter, which I just print. And there is an x and a y parameter, which I multiply and return. And when you call this function, you have to specify at least one parameter, which is the x. And when you do that, then all the other parameters will take their default values. So when you call the function fun with the for, and you assign it to a result, then this will inside print the string s, which is the default value. So you will get a default. And when you print what is coming out of this function, you will get an 8. Because it multiplies the 4 with the 2 that is default. One interesting thing about parameters in Python functions is that they are named parameters. So it is not important in which order you give the parameters to the function, but as long as you specify all the parameters that has no default value, you can do that in any order. For example, when you call the function s, the function which the parameter s equals other, x equals 2, y equals 6, then this will work exactly the same as if you would have said function 2, 6, other, just that you now use the parameter by name. And the interesting thing about this is that you could have left out the y parameter. Then this would have taken the default value for the y parameter. In C++, there is some similar concept, but you can only leave the last parameters, which is not the case here. Here you can leave out any parameter you like, which has a default value. Okay, and so the result is that it will print other, and of course, 2 times 6 is 12. There are many more elements in the Python language that, because of a short time today, I will not be able to talk about. So which the non value, which is just a a value that you can use everywhere where you do not know anything about it. You can have classes, you can have modules. There is a proper exception handling. You can have lambda functions. There's string parsing and formatting, input, output, and so on. And when you open the PDF document that you might find on your desktop, these are all linked. So it does not show the links. All right, but this will always link you to more information about these. All right, so now it's time for you to see what you have learned so far. We will just try to write a small script that will receive a number from the command line, and that will multiply this number from the command line with a list containing the values from 0 to 9, and write that to console. So what you should do is to open a Python file, for example, the move.py. You will have to get a number from the command line. As a hint, you should use the sys.argv of 1. You should create a list of numbers from 0 to 9 using the brackets. You should write a function that takes a list and a value, does something, and returns the elements of the list multiplied, each of the elements of the list multiplied with the value. You will call this function, and you will print the rest. And the expected result is, so when you call Python mod.py with the 10, you will get the values from 0 to 9 multiplied by 10. So 0, 10, 20. I guess I will give you like some amount of time to actually do that, and then I will go line by line through the code and see what should happen. And if you need assistance, then Andre is there, and Laurent there, and me as well. Yeah. So it's written here, the indicator said that you are on console and not in the Python console, in the terminal. So. Okay. All right. So, okay. So we will go through it line by line. So the first thing, edit the mod.py. And so the first task is to get a number from the command line. As always, when you write a Python script or when you use Python, the first thing you do is you import the modules that you need. So the first line should be import this. And then you want to have the sysargv of 1. But since by default all parameters given to a program are strings, you have to convert them into an integer or a float by using the int or the float function. To get a list with the elements from 0 to 9, you can just open square brackets and write 0, 1, 2, 3, 4, and so on. But there's also a range function defined which just does that for you. So you say how many elements you want to have, in this case 10, and this will generate you the range from 0 to 9. So the function might be a bit more tricky. So first, the definition of the function. Here, I just take 2 parameters, the list and the value. I define an empty list at the beginning, and I iterate through the given list and append the value inside the given list multiplied by the v and return it. Okay? So, and as a remark, you might see that there is no begin and end keyword, no parentheses, but just everything relies on indentation. Okay, then you call this function and assign so find with lst and val, so with this value in this list, you assign it to a new list, and to print the list finally, you use the print statement, the print command, and yeah. Okay. Okay. So far the first practical session. Of course, what we really want to do is to do science with Python. And to do real science with Python, there are some modules which will be also partially used later on. So there is the built-in module math, which defines like basic functions like the square root, the sine function, the logarithm, the power function, and pi. There is, you can do a linear algebra, simple linear algebra with NumPy, with the NumPy module. This defines, for example, a dot function, which is an inner product between 2 vectors, which defines a norm function, and which you can use to solve systems of linear equations. And you also have advanced mathematics with SciPy, where you have some clustering algorithms, FFT, curve fitting algorithms, statistics, and so on. There's a huge list of things you can do with SciPy. And please, so for today, I will just give the small list with the links so that you can have a look at that later on. But what I want to talk about today is how you can use Python for plotting. There is one module that is called the matplotlib, and the plotting tools are in a submodule of it, which is called a pyplot. So when you want to plot with the matplotlib, you have to import matplotlib.pyplot. And since it is very difficult to always use this long name when you want to actually use a function of that. So if you want to plot, for example, you don't want to write matplotlib.pyplot.plot. That's why we just define an abbreviation for that. You might remember that this is just an object as everything else, so it can be assigned to any variable. And I assign it to MPL, so then I now can say mpl.plot. And for this first example, we just plot range 10. We just saw the range keyword, which means the values from 0 to 9 with the red line with line width 2. So these parameters are basically the same as you would use in MATLAB. I have no example how this looks, but then you can modify the plot. It's the same as you would do in MATLAB with pointing and clicking. You just do it here on the command line. You say you want to have an X label. And it's very easy to save these plots to file of various formats. This includes any vector graphics. This includes PDF. This includes JPEG, and whatever you want. You just say matplotlib.savefig. You give the extension, and it will automatically save the file, this plot, in the format that you specified. I think the savefig function has also different parameters. So if you want to save as a JPEG, you can, for example, specify the quality you want to save and so on. And if you have done that, you could probably open the figure.png and you will see the plot that came out. Later we will see an interactive plotting environment where you can actually see what you just plotted, and you do not have to write it to a file. Okay. So, and the rest is more or less similar to MATLAB. There is a list of functions that you can use, which is, the link is provided here. But it's more or less the same as MATLAB. You can have a log plot, semi-log x, semi-log y, and so on. Bar plots. You can generate basically everything that you can generate with MATLAB. All right. And now we come to the second part, which will be mainly the last part of my talk. It's another hands-on for you, where we just want to generate a simple plot and write that to file. So again, since we probably want to reuse that, we do not plot this in the console, but we open a Python file. We create a list from -10 to 10, maybe using the range function. We create a list of squared values from x. And we plot y versus x with the blue dotted line of width 4 using the plot function. We add x and y labels, and we write the plot as PDF. So of course, the first thing you do is, again, you open the plot.py on the console, and you start writing. Maybe you get some help from the help of the range, that you can specify not only one parameter, but also two, begin and end. And if you want to have numbers from -10 to 10, you start at -10 and you end at 11, because you are, again, one behind the last element. For the third point, to convert one list into another one, I just showed you So of course you can do the for loop again, the same as before. But I also already showed you that you can use some list comprehensions. And this makes it just much easier and much faster. And I think it's even more beautiful than just writing this huge for loop. When we want to plot, again, we import the matplotlib.pyplot. And there's also a shortcut for importing it and renaming it. You can just say import matplotlib.pyplot as, and then you give a name. That's what I do here. You plot x, y. You specify that you want to have a blue dotted line with line width 4. You can write the line width. You can use the abbreviation LW. Both works. You add an X label and a Y label. You save it. And of course, when you are on the console, you also have to execute it. And this is as easy as calling Python with the plot py. And then you will get the PDF that I just showed. All right. So okay, because in the range you specify the first element and behind the last element. Yes, yeah, exactly. It's the same as in C. To get from -10 to 10, including, you have to specify 11. Okay, so that was it from my side. I just want to give a short summary of what I just showed. So I just introduced you to Python, and if you want to learn more about it, because this was really just a brief introduction, and of course did not cover all the possibilities that you have in Python. There is the Python web page first, which has installation instructions, so how to download Python, how to install it. There is a very good tutorial. There is also the language reference, which defines what elements are in the language, how a class looks like, how a function definition looks like, and so on. And there is a standard library containing all the standard libraries, like the sys module, like the mass module, and so on, what I've shown you. There is a nice list of Python books, which you can find here. And there's one of these Python books that I want especially to highlight, which is called Dive into Python. And this is, again, a very good introduction and step-by-step introduction, which is a bit different than the usual introductions into programming languages. But it's very interesting to see that.
They're all free.
They are all free. Yeah. And at the end, again, some links to some Python libraries like the NumPy and SciPy, the matplotlib, Bob that Laurent will talk about, and a list of available Python packages that Andre will talk about in more detail. Okay, thank you.